Hello, Chemistry 10HH students. I'm on the 4th page of your study guide. So for number 8, I'm looking for something with 4 valence electrons. So A is out because it has 1 valence electron. B is out because it has 2 valence electrons. C checks out. I've got 2 from the S, 2 from the P. D is incorrect. That's 8 valence electrons. And E is incorrect. That is 8 valence electrons. So the correct answer here is C. Moving on to the next one. So it's kind of hard to do this with just equation editor. I'll do my best for this. So all of my numbers check out. N is 1, L is 0, ML is 0. So MS is just going to be equal to positive 1/2 and negative 1/2. So that will lead to 2 electrons. Or another way to think about it is just it's an s orbital. Right, so now I've got N is equal to 3, L is equal to 1. So I have ML is equal to negative 1, 0, and positive 1. Each one of those could have up to 2 electrons each, 6 electrons. Or you could think of it as that's just 3p. So there's a couple different ways you could approach this one. If you just know it's n squared, it's going to be 16 electrons. That works. But the reason why that works out is L can be equal to 0, 1, 2, or 3. So for ML is equal to 0, or sorry, for L is equal to 0, ML is also going to be 0. So that's just 1 from there because of the plus 1/2. I also have ML is equal to negative 1, 0, or positive 1. And then I have that ML is equal to negative 2, negative 1, 0, plus 1, plus 2. And then I also have it being equal to negative 3, negative 2, negative 1, 0, plus 1, plus 2, plus 3. Each one of these ML values, I'm not multiplying it by 2 because the question says that MS is plus 1/2. Add it all together and you get 16. And then for D, all of the numbers check out. So anytime you have 4, they check out. The answer is always 1. That's because of the Pauli exclusion principle. Right. So now this is just a wavelength frequency question. Before I do anything else, I am going to convert 515 nanometers to meters. If you need this conversion on the test, I will give it to you. Right, so I'm going to calculate the frequency first. C is a constant. I would highly suggest putting it in your calculator. Take this moment to check if it's in your calculator and that it's in there correct. I'm going to round this to 3 sig figs. And just a quick check, the fact that it's an order of magnitude of around 10 to the 14th hertz, that's pretty normal for what I would expect for frequency to be. So I'm pretty sure my answer is right. And then I can just plug this into the next equation. And then I get 3.86 times 10 to the negative 19th joules.